MT330 folks who aren't here, which is a lot of you. Just doing some warm-up stuff before we just work on things today. I've asked everyone to take this function and sketch its derivative accurately underneath. You might want to pause because we've been working on this for a little bit, and since so many folks are missing, I thought I'd record this for you. That looks great. Yeah. So if this was a perfect circle, what would be the actual behavior here? If this was a true circle, this is close, but what would be happening at 1 and minus 1? It's something a little bit different. It's very similar to what you have, but if we were going for ultimate precision, what would be happening there? What does that tangent line do? What does the slope become of that tangent at those side points? Yeah, and yeah, that's it.
Yeah. Wait.
Yeah.
No, this is
No,
just
it
my
should.
line.
No, that would be good if it was. That would be good.
Sorry.
This is kind of what I was hitting at Jack about. That if this is a true circle, that slope actually becomes infinite, so kind of undefined essentially. So there really isn't.
Okay, so I should.
Yeah. That was great.
Okay.
Okay, that's what I was thinking. Yeah, that sounds about right. So, just looking at this, right? Yeah. So I would first draw the picture up. I would get that picture drawn. Let's get that down on paper, because it'll help you think about it, Lisa, for sure. So what we're going to do is we're going to imagine the tangent line and its slope. So like right here, what is that slope? And you can't, is it a large value? Is it positive or negative? Positive. It's pretty steep, right? Yeah. So it's a large value. What's happening to it as I move this way? Yeah, there you go. Okay. And then what happens to it on this side? Yeah, and then it becomes more normal. So just put a graph right underneath and indicate, so that was -1 and that's 1. You'll want those down here. And just express that as your vertical output. So the slope here, large positive number right here. Just put it down. Right in the center, it's 0. And over here, it's a very negative number. Is that making sense? Mm-hmm. And then there's kind of this gradual change. So it won't be a straight line, but there you go.
Thank you.
Yeah, you're welcome. Hey, Lorelai, I'm happy you're here. It's a big ass water bottle, Jack. A lot of fluids.
Yeah.
Athletes got to be fluidated. Whatever that means. So, Lorelai, we are just doing some warm-up problems before we work on things today. I'd asked everyone, and I'm pretty much going to go through it in a minute here, but I got a few more. Sketch the derivative of this thing right down below. I gotta check on Carolyn. How's it going? How you feeling?
Not great.
Okay, let's go through it together.
Yeah.
Okay, cool. So, remember that derivative, this is the key to remembering and helping yourself get going on any of this stuff, equals the tangent slope. That's the key correlation to make. And once we have that, then at least we know what the heck to do. So let's start at just this left side. I'm going to work left to right. You want to, in your mind or on your papers, this is why I encourage Louisa to draw this out, because it really helps to just take a pencil or make these little sketches of tangent lines as we move from left to right. And that was pretty bad. That was a pretty bad tangent line. So you ask yourself, okay, over here, what is the slope. And I'm gonna ask you, Caroline, is that positive or negative?
Positive.
Positive, and is it a steep slope? Ish.
Kinda,
Yeah, like it's pretty steep right over here, right?
Yeah.
And so that's a large positive value. So we'll just say, okay, over here, we've got a large positive slope. Remember, this is just the slope of the tangent, right here. This just means the derivative of f. And then, Caroline, do you mind if we keep talking just a little bit?
Mhm.
Cool, thanks. What happens to that slope as I move to the right?
It decreases.
It decreases, and what is it right there?
0.
There, perfect. So let's grab another easy point. Those zero slopes are gonna be anchors to help us get the sketch made. So what I have to do between here and here is just show this tangent slope starting out very positive and trending towards 0. Does that make sense?
Yeah.
Does that sound good? So what about the other side? I'm not gonna bother Lorelai yet because she's just getting warmed up. So we'll just keep talking.
Okay.
So what happens over here?
It's the opposite.
Yeah, what do you mean by that? You're right, but a little more precisely.
It gets steeper as it goes down.
Yeah, so is that a positive or negative steepness?
A negative.
Negative, right? So on this side, right out here, it's very super steep.
Mm-hmm.
And I just gradually, this 0, -0.5, -1, -2, -3, -4. So I see that thing trending toward a super negative value. Now, the thing I said at the beginning was, hey, this doesn't look like it, but let's pretend this is a perfect circle. What is the slope right on the edge? And maybe Lorelai can help me with this one, because this is kind of fresh. So like right on the edge of a circle, let's just imagine a perfect circle. What would I say about that slope right on the side?
Would that be getting ready to go towards negative?
It would, yeah, if I move down this way, definitely, and it's positive this, yeah, absolutely.
So 0 then?
So 0 is perfectly horizontal. What's kind of the opposite here? What's the steepest you can get? What's the largest positive number you can think of? Maybe that's maybe that's a weird question. It could be. Where, if I kept going here, getting steeper and steeper, where am I headed?
Infinity.
There we go, thanks. Just evident. Yeah, because you probably weren't quite sure what I was looking for there, like if I was looking for a number. So right at the edge, so let's keep this in mind, that a vertical slope, that a vertical line has infinity as its slope. And plus or minus infinity, it kind of depends on how we get there. But since everything here is positive as I approach this way, I'm going to say that's a positive infinity. So I'm going to actually, if I wanted to make this 100% precise, I would put asymptotes here. And then on the other side, that becomes negative infinity. So I would put an asymptote right there. So that's the most accurate version of this thing that we could make. But if you were getting anything, even though just picking a couple points and doing that, you've got the idea. And that's great. Is there any questions on that at all? Because I got another one for you. So here is another. I'm going to give you a little outline for maybe how to think about this. Bless you.
Bless you.
Thank you.
2 minus 2 minus 2. So this is f of x. So a couple of things to ask here. One is, where is f prime equal to 0? So what x values give me a 0 slope? Step 2 is, where is the derivative positive and where is it negative? And for these, I would like these are going to be open intervals, so let's use open interval notation for that. Let's try that. Do the visualization. Draw that thing out on the paper to help yourself. Helps the processing begin. Hey, sorry. I'm just glad you're here. Definitely get a chance check out the very first part of what happened today. We're just so Mace, we're just working some warm-up problems before we work on homework and stuff. Bless you. I'm gonna run to the restroom real quick. Be right back. this one?
I think okay.
You think okay? Can you
Maybe
feel
both.
like working with me on this?
Sure.
Cool, thank you. So where is f prime equal to 0?
-2 and 2.
2, and what is helping you see that? What are you using?
It's like stops. Your marker would end. That'd be
So-
flat.
Horizontal tangents.
Yeah.
Yeah, exactly. Cool. So remember, f prime is just the tangent slope at the point. F prime of x is the tangent slope right above or below the point x, and that's a horizontal tangent. So we're going backwards. Look for the horizontal tangents, grab the x coordinates where they happen. So Hannah got that just perfect. X equals -2 and x equals +2, solid. How about the next one? Where is the derivative positive?
I'm not gonna lie, I forgot to answer this question, but is it just like from infinity to -2? Negative infinity to negative?
Yeah, absolutely. So definitely. So Hannah, you're looking here and you're seeing that and we're imagining this continuing, which is exactly what I was hoping would happen. So there I have a positive, super positive, right? Like very steep, becoming less, but right here in this region, f prime is positive. So here we have a positive tangent slope. Yay, right? So f prime is positive, solid. Is there anywhere else that happens?
From 2 to positive infinity.
Absolutely. So it's also increasing here. Were you going to say that, Mace? It looked like
Yeah.
maybe, yeah, nice. So right here, I've got positive slope. So in this region right here, I've got positive slope again. So f prime x is positive. And if we're going to write that, we would say f prime of x is greater than 0 when I would say on these intervals, -infinity up to 2. We don't want to include 2 because -2 because it's 0 at -2. So we skip that. And then here I'm just going to union that, say I've also got another place that happens, and that's from 2 to positive infinity. And then we got the last part. Where's it negative at?
-2 to 2.
Oh shit, Mace is stepping in there. Nice, absolutely, my friend. -2 to 2. Right in the middle here, between these two places where it's 0. So on -2 to 2. Good work. Is there any questions at all on that? We're just warming up a little, doing some practice work. You good on that, Lorelai? Cool. All right, challenge time. Something we haven't done. Same ideas, backwards. So we're really working out today, lifting the heavy stuff. So this is going to be backwards. I'm going to give you the derivative graph, and I would like you to give me the original function graph. So, given the graph of the derivative of f, sketch the derivative, sketch the graph of f. So this is going to be the graph, and I'm going to give you, you need one extra little bit of information, and I'm going to give you that. So let's start off chill. So this is f prime of x, this is x, and this is just 2 on the y-axis. And the graph just looks like this, straight across, horizontal line. So what I would like you to sketch underneath is f of x, but I want you to assume that f at 0 is 3. I'll give you that point. What's the rest of the graph? So you gotta kind of work this backwards. Remember, this is the slope graph, tangent slope graph. So take a minute. This will be so good for you. Doing this, it's medicine, good medicine, math medicine. Anybody in here ever played Dark Souls video game? Praise the sun.
Yes, son. Gotta love Coneheads.
Got a what?
Gotta love the Coneheads.
Oh yeah. Oh, yeah. Yeah.
It's been a while since I played that game.
Did you play Elden Ring?
I did not. I bought it and I've never played it.
You gotta get on that.
I-
I mean, after school.
After school.
Don't
After-
do math now.
Once I knock out this class,
Yeah.
I'll get on it.
You'll, yeah, absolutely.
I did Dark Souls all the way through on the hardest difficulty without dying, and that was
Well
that was a 5-hour long excursion. It was rough.
5 hours. I spent 700 hours on it.
I was, I
Like a total loser. I spent 700 hours on it.
Don't feel bad. I have like 3,000 hours on CS:GO.
On what?
Counter Strike Global Offensive. Got way too many. It's kind of disgusting.
Yeah. It's the kind of thing only a gamer can.
Yeah, it's just
tell.
like
Otherwise, people think.
it's only a flex to other people. If you
Yeah.
understand it.
Exactly. Okay.
You know,
So wait. So say that a little more.
For the,
Yeah.
because it's just a different one for the job. And change the slope of it.
Right. Yeah. Yeah.
So do we choose for ones like?
So I'm curious how you're coming up with two. So like you're saying like this kind of, because so like if on this side that would be a negative slope, and we just got a positive. You're thinking, you're definitely thinking right. What is the tangent slope everywhere on that graph?
0.
You're going backwards. It's 2,
That's right.
right? What does it look like if your slope is always 2?
So it would be consistently like that. Okay.
Yeah, it passes right through there. Does that make sense?
Yeah.
Yeah, cool, good work. Okay, are you feeling like you're acclimated? Yes. What is the slope there? So I'm just curious, that's actually right. Well, yeah, beautiful. If you want to get super fancy, give me the equation of this. F of x equals what? You can write it out. You got
Oh,
it. Yes. Beautiful. Oh yeah, so good. Yeah, that even looks like a slope too. Nice, very nice. How we doing here? Yeah, let's talk. What is that graph telling us about the tangent slope? No matter what x is.
It's 2.
It's 2. What does it look? So it's like that, right? And no matter where I move, it always looks like that. It doesn't change, so there's no change in how we're increasing or decreasing. What could that look like if it's always 2?
Positive slope.
Positive slope, definitely. What kind of things have constant slope? The slope never changes. What does it look like if your slope never changes?
It looks the same.
Yeah, that's a good answer. What shape?
Oh.
Yeah. Perfect.
Okay.
That's it. Good. Oh. Well done.
For whatever reason, the homework is not that they're not helpful, but like the homework applied really I immediately picked up. I was like, oh, homework.
That's awesome. I love hearing that. That's fantastic. I'll have to give you harder homework, Mace.
I didn't ask for that.
No, I think you did. I think you did, and everyone heard you say it.
I'm calling them 4K.
So, a line. We have a constant slope. The only things that have constant slope are lines. And the slope is always 2. Could someone give me the equation of this thing? What is a line with slope 2 that goes through y-intercept 3 look like? What's the equation of that? Katya, you...
2x plus 3.
Oh, beautiful. Thank you. So good. we actually can even get the equation of this thing. Slope of 2, this is the y equals mx plus 2. That's what Katia was using, I believe, in her mind. Cool, well done. All right, well now we gotta boost this up just a little. I got one last one for practice. I've got another assignment I'm creating for you all. I don't have it yet, but I will get it to you hopefully tomorrow. Because I don't want you to not have math to do. And I know you feel the same. We have such little time left together. Oh, I can't abide. All right, there we go. And so this one looks like this. This is f prime of x. This is the point 4 right here. And you can make that whatever slope you want. It's not really matter. It doesn't really matter for what we're doing here. Let me give you a point. And the point I'm going to give you is at 4 down here. And it's going to be 4, negative 3. So I'm giving you that point on the graph. What'd that look like? Just take some samples. Do some sampling here of what is the slope. And you're not grabbing this slope, so what is the value? You know, so like right here, the slope is a negative number. Here the slope is also a negative number, but it's a lower negative, it's steeper. So we have steepness going to less steepness, and then a change of sign in the slope. What's going to happen here? I'm going to remake my graph because it's a little low. I see. So let's, what is the slope right at 4? The tangent slope right at 4. Can't you see a pencil? I want to help you. Let's label some things to help our brains. So this is f prime of x, but that's the tangent slope. Let's just have that there on the page so we can keep that in mind. So what does it look like when, what is the tangent slope right there when x equals 4? What is the y value right there at x equals 4?
0.
Yeah. What kind of slope has slope 0? What does that look like? Yeah, right on. So we know that we have right at 4, and you can kind of sketch them out down here. I have a horizontal tangent like that. Okay. Now, what happens as I move to the right of 4? What happens to the slope of that line as I move this way? Yeah. So if I move out this way, does that mean I'm increasing or decreasing? Yeah, right. So let's check this out here. F is increasing on this side. What is F doing on this side?
Decreasing.
Yeah. I'll get my hand out of the way a second. Yeah. So we have this point. We're decreasing on the left side of it, and we're increasing on the right, and we have to hit that point. What might that look like? Just take a moment, pull it together. I don't want to. I don't want to lift you over the finish line. I want you to do that. There we go. Oh, yeah, looks great. Yeah, lovely. Solid. Yeah, that's looking good. I don't know about that left side, but I love that right side. Yeah, the left side's a little whack.
Okay.
So one thing to think about here, Caroline, is you got this side right. You saw that f, the derivative is positive over here, so f is increasing. What is f doing over here? So first off, what is the sign of the derivative to the left of 4? Is it positive or negative?
Negative.
What does a negative derivative mean, increasing or decreasing? Yeah, so as I approach that point from the left, I have to always decrease to it.
Okay.
What would that look like? You're gonna
So
touch that point.
It's gonna come from up there.
There you go.
Okay.
That's it.
Perfect.
Yep.
Thank you.
Yep. No, okay, I'm coming around. Oh, this is great. Finally. I have to help you. This is fantastic. Good. I've been waiting for this all semester. So, this is my tangent slope, right? Where's the tangent slope 0? And let's ask this. Can I use your pencil for a minute? So this is equal to the slope. Let's put that right there. So this axis, the height here, represents the slope at that point. So what is the y value right there? Right at that point. You already have it there.
Oh.
0. So at x equals -4, x equals positive. That's actually a positive.
Oh.
Yeah, it's all good. Did I write -4?
No.
That's okay. That could have been confusing. Yeah. So right at 4, I have a horizontal tangent, so I can just kind of sketch it. So now, to the right of 4 is f prime positive or negative on this side, this right side. It is positive. Does that mean I'm increasing or decreasing? Increasing. So on the right side of this, I'm increasing. What am I doing on the left side? Yeah, because it's negative on the left. How could that, what kind of picture would make that happen over there? Decreasing on the left, increasing on the right. Does that make sense? Yeah, good. Oh, that's beautiful. It's a little sharp, but it's the right idea. Oh, you didn't have to erase. Just like wipe it out. Yeah, no, it's just those sharp points indicate a jump.
Okay.
So that's kind of like that looks like a constant negative. So that, yeah, a gentle. Yes, lovely. Oh. Right idea, wrong place. Right idea. So right here, when I look at this, Mace, it has a horizontal tangent at x equals 0. But where should that horizontal tangent be? Looking at this. Yeah, right under 4.
Under? Or
Yeah, so look here. So I gave you this point. We have the point. It's actually 4, -3. So let's put a little dot right there. 4, -3. Yeah, perfect. And then a little tick mark there for me. Just do it that way. Thank you, sir. So right at that point, I have a horizontal tangent. What is f doing to the right of 4? It's increasing. So we're gonna do this. So this shape here, just the vertex should be there. Yeah.
Cool.
Does that make sense?
Yeah.
Okay, cool. Good stuff, my friends. Can I answer any questions on any of this? Do folks still have homework to do?
Just the I only have to do, I did 2.3, I just need to do the workbook thing that we moved to Friday.
Yeah, what was that? Remind me of what that
It
was.
was the pages, yeah, page 84.
Oh, the written
The
homework.
written one, that's,
Yeah, and I'm thinking that we're probably not gonna be open on Friday if things go well, if the snow really hits like it should, we might not be
I'm
open.
praying.
I am praying too.
I'm checking, I'm gonna be up at night checking with my bags packed, ready to go to the mountain.
You hoping your restaurant closes?
Yeah, but it's corporate, so we never close.
Yeah, those assholes.
Yeah.
It's brutal.
Go home.
So let's take the rest of the time to finish up stuff. If you're already done, you can stay here and work. I am gonna come up with a new assignment, I don't quite have it yet. So I can tell by some faces that some people are already done. So do what you need, but I'm here, let's get that homework knocked out. Remember, we have two things, we have a written assignment
And it's 2.3.
and the myopia math, yes. Yes, ma'am.
Good job, team.
I'm done with both,
Indeed.
but I just have a question on some.
Yeah, let me come
Oh,
around
I
so I
got
can
one
see it
exactly better.
better.
But which one should I?
It's been so
Mhm.
long. These ancient texts have never been open.
Which one are you want me to look at?
Mine,
Cool.
Which, like, ones that are not continuous, so, I'm gonna say that work conditions. are-
Oh, gotcha.
And then the brown one,
That's great.
that I thought,
I think that that's actually the case.
okay.
Yeah, there's nothing like this in there.
Yeah,
Or
this isn't
or
one,
one with,
this one was just the first one, which
Yeah.
violates 1 and 2.
yeah, in retrospect, it was kind of not a great problem set because it didn't include that particular condition being violated. So
I just wanna make sure.
yeah,
we're
you're
doing it
you're not doing it wrong at all. This looks great. I can check through the rest of this if you want.
Yeah.
Yeah, they were pretty easy, weren't they? Yeah, too challenging.
Yeah, I guess you're just seeing these, right?
Yeah. Oh, okay, gotcha. Yeah. No, looks beautiful. Do you want me to just take it?
Yeah.
Okay, thank you, ma'am. Stay or go,
Okay,
and
thank
I'll
you.
send out an email about things that, yeah, the next thing. So if we are open on Friday, please pop that homework into my box outside my office. If we are not, just bring it on Monday, please. That'd be great.
Do you want to
Yes, sir. Yeah. Oh, I'm sorry, what's the?
This is just the homework.
Oh, okay, cool. Did you want to turn it in?
Yeah, sure.
So on this one, yeah, okay, that all looks great. I got it.
Yeah.
Yeah, I'm with you. They weren't very interested, unfortunately. Let's make sure we get any other things. Thanks, Jack.
You want this?
I got it.
Okay.
What's on the back
I
here?
don't know, I think that's just my note.
Okay, yeah. I was like, well, that's a strange side to start on, but it works,